I hope I'm saying that right, Matt. Do you want to come on and ask your question? Okay, right here. Could you
Yep.
explain so in the bag, what's in the bag?
So this is actually a demonstration of what we call our generation one fuel, where we disrupt the oxide layer. The aluminum isn't shiny like it typically is. That aluminum oxide, that aluminum rust is what prevents it, typically from reacting with water. So the aluminum soda can or aluminum spoon, right, they don't react with water, shiny silver aluminum oxide. But with our generation one fuel, we strip away or disrupt that oxide layer, and then that makes the aluminum water reactive. Since then, we've actually, and this video is showing that Gen 1 fuel because it produces the hydrogen immediately and you can visually see it. Since then, we've upgraded improved our technology. Our generation two fuel does not require that pre-processing steps. And now you can just pour raw aluminum into our reactor, like we showed here, and along with a small amount of additive, it mixes it with water and turns it into hydrogen. But it works on that same principle where you disrupt that oxide layer so that the aluminum, when you pour it into the water, aluminum likes oxidizing. It'll oxidize with the H2O, or rip the O off, and allow the H to go free.
So interesting. This might be a silly question, but um, I'm always curious in ways that we could store hydrogen or make hydrogen in a way that maybe doesn't need to be liquid or cryogenic, subcooled. Would it be possible to generate this hydrogen on board of an aircraft, or would that require like too much additional, then you need your reactor and water, et cetera? Have you guys
Yeah. So
looked
the
into
challenge
that?
is the water. Right? The challenge is the water.
Yeah.
Water is heavy. That's
Mm.
why we've been, when we illustrate our air, ground, and maritime, the air system, the reactors on the ground, it basically acts as a mobile gas station. The ground system, they produce hydrogen and it's consumed on demand. Right. So as soon as you produce it, the fuel cell consumes it and it produces electricity. But the
Mm.
maritime is what you were envisioning, where you have the reactor on board the platform. So you have the reactor on
Oh,
board the
yeah.
water. It carries aluminum. It can also then ingest water from the environment and produce hydrogen on demand.
And then you guys make the pellets, excuse me, correct?
Yeah. Yeah.
That's your
That's a
entire
fairly straightforward, mechanical processing step.
is it
Yes.
what's the
So make the
energy
aluminum.
requi
So total all-in energy to take the aluminum, raw aluminum, let's say some form factor like I don't know, some sheets, process it, put it through our reactor. The water pumps operate; those consume a little bit of electrical power, and then produce hydrogen through electricity through the fuel cell. All in, um, consume about 1.8% of the energy that comes out.
Mm.
So aluminum has twice the energy density of diesel, 8 kilowatt hours per kilogram, maximum, 8.6 kilowatt hours per kilogram. That's the amount of energy. That has come from some sucker putting the energy in, right? You start with bauxite. Smelting process for aluminum is very electricity intensive, right? So all the energy is embedded in the aluminum. We're basically
Mhm.
undoing, we're recapturing that energy that somebody else at the smelter put in. And because we're just doing mechanical and chemical steps, it's highly energy efficient. Again, only 1.8% of the energy that comes out, you need to put it into energy.
Oh, that's so interesting. I could definitely ask you questions all day. I think I will need to get you on my podcast,